In this lecture, we will discuss about bulk modulus, expression for bulk modulus. This question is asked for 8 marks. We will derive an expression for bulk modulus of elasticity K. Before deriving bulk modulus of elasticity, I need to tell you about two parameters. The definitions of these two parameters is important to understand this. One is alpha. This is called as elongation strain. You need to know what is elongation strain. This is defined as change in the length of a material per unit length per unit stress. Please understand, it is change in length per unit length per unit stress, per unit length per unit stress. What does it mean? Suppose you have a material whose length is 1 meter, length of a wire. I apply a stress T is equal to 1 Newton. Okay? The change that takes place in this. Okay? This change is alpha. Elongation strain is the change per unit length per unit stress. For example, see here. Suppose if alpha is the elongation strain, alpha is equal to 10 meters per unit length per unit stress. So it is 10 Newton per unit stress. Okay? So unit of stress is Newton per meter square. If alpha is equal to 10 per unit stress, if length of the material is 5 meter, then if the stress applied is 5 Newton per meter square, what is the change in length? Change in length is alpha into given length into stress applied. Alpha is 10 into 5 meters into 5 Newton per meter square. See, this Newton per meter square, this Newton per meter square will cancel. So you will only have meters. So it will be 55 meters. Please try to understand this. Change in the length of the material per unit length per unit stress is elongation strain. Now similarly, we have what is known as compression strain or compressive change. How do you explain this? I will give you an example. Look at this elastic material. Its length is 1 feet. Now I apply force stress on this. Its mass change, its length changes. For a given stress, the change in length per unit stress is known as alpha, elongation strain. But what is compression strain? Observe carefully. As I increase the length, please observe the decrease in the width of the material. See, it is becoming thinner and thinner. Do you see? The width of the material has reduced. So, what is compression strain? Compression strain is net decrease in the width per unit length per unit stress perpendicular to the direction of the stress. Stress is applied like this, but decrease in the width is perpendicular to stress. Do you understand? So if length is increasing in one direction, there is a compression happening in the perpendicular direction. So beta, the compression strain is defined as, see this, beta the compression strain. Okay, this is change in length per unit length per unit stress perpendicular to stress. See here, this change in length is happening perpendicular to stress. Stress is applied like this. Look at this. The stress is applied like this. Okay? Perpendicular to the direction of the stress, the width is now 5 millimeters. See, as I increase it, the width is coming to 2-3 millimeters, correct? So, when the stress is acting like this, the compression is happening in the perpendicular direction. This is called as compression strain. Okay? Compression strain beta is change in length perpendicular to stress per unit length per stress. So it is, unit is same as alpha, but here we must realize whenever there is a stress in one direction, it causes elongation in one direction, and also this is accompanied always by compression in the perpendicular direction. Do you understand? Every stress produces elongation in one direction, and it is always accompanied by compression in the perpendicular direction. So now I'll give you a small example. Look at this. Here is a material. Okay. The length of the material is 3 meters. Let a stress of 4 Newton per meter square is applied along this direction. Okay. Let alpha be its elongation strain. Right. So now when the stress is applied, net elongation or change in length or increase in length is equal to alpha is net elongation per unit length per unit stress into given length into given stress. Now, because of this stress in the perpendicular direction, this width will decrease, perpendicular direction. Suppose if beta is the compression strain, then change in the perpendicular length. Perpendicular length is width, okay? Change in perpendicular length or width is equal to beta into, if the width is 1 meter, stress is 4. Please remember, the stress, this stress is perpendicular to this width. Okay? Because of the stress in this direction, there is elongation in this direction and also accompanied by compression in this direction. So every stress always is accompanied by elongation in one direction and compression in the other direction. We need this information for the very important derivation on bulk modulus. So I imagine a cube of unit length acted upon by 3 perpendicular stress. So look at this. Here is a cube. Okay. Let its length be 1 meter. Now let there be a stress perpendicular to this. Let us call this as ABCD. Call this face as PQ, RS. Now, see here, let this be x-axis, let this be y-axis, This is Z axis. Now, suppose if I apply a stress in this direction, I call it Tx. What will happen? The length AB will increase. Suppose if alpha is the elongation strain of this material, length is 1 meter, stress applied is Tx. This is the change in AB or increase in length. Correct? Because of the stress, the length increases. But at the same time, due to this stress, perpendicular width BS will decrease. Not only BS, this is also perpendicular to this, correct? So, this is one perpendicular length to this, and also this is, because y-axis is perpendicular to x, z-axis is perpendicular to x, this stress Tx is along x-axis perpendicular to y and z, and because of this stress there is an accompanying compression along z-axis and also y-axis. So now this is elongation, I will call it. Okay, elongation along AB. At the same time, compression it causes along BS and BC. Okay, now just imagine if there is a stress in this direction, I call it TZ. Okay, this is X, this is along Z axis. Now along Y axis there is a stress. Here this is TY. So now there are three perpendicular stress on this cube which will change the volume of the cube. What is the change in volume to the original volume? That is bulk strain. Bulk modulus of elasticity is bulk stress by bulk strain. So we need these definitions to calculate bulk strain when all the three stresses are in action. Now tell me, what is the elongation in AB? It will not be just this minus, because of this stress the length AB experiences compression. The stress Ty is perpendicular to x-axis, so this causes reduction in AB. So if beta is the compression strain, the reduction is beta into 1 meter into Ty. This is also minus beta into 1 meter into, see, Tz is perpendicular to AB. So this stress also causes compression along AB, therefore Tz. Please, if you are able to write this expression, this derivation is done. That is the most critical point in this derivation. See here, change in AB now. I call this as change in the length of AB due to this stress which is along AB is this elongation. But the two stresses are perpendicular to AB. We now learned that whenever a stress is in one direction, it causes compression in the perpendicular direction. So this stress causes this compression. This stress causes this. Now, see here, change in length of BC, let us say. Apply the same logic. Elongation along BC due to this Ty is alpha into 1 meter into Ty minus compression of BC due to Tx and Tz which are perpendicular to BC is beta into 1 meter into Tx minus beta into 1 meter into Tz. Please carefully observe this. Next, change in AB is over, BC is over. Now I will take it RC. Okay? Is now this stress is along RC. This will cause elongation in RC. Therefore, alpha into 1 meter into Tz. But these two stresses cause reduction in RC because they are perpendicular to RC. Therefore, beta into 1 meter into Tx minus beta into 1 meter into Ty. Do you understand this? Now, change in AB, change in all this, I got it. So, we will calculate now change in volume. So, here, what is the final length of AB? Its original length was 1 meter, correct? Change is this, okay? Therefore, 1 plus alpha Tx minus beta Ty minus beta Tz. This is the final length. Initial length plus change. Final length of BC is 1 plus alpha Ty minus beta into Tx minus beta into Tz. Final length of RC is equal to 1 plus alpha Tz, see this, xyz minus beta Tx minus beta Ty. xyz, here xy, x, y, z. Here also you have xyz, y, x, z, z, x, y, correct. Is it correct? Now, change in volume. What is the initial volume? Initial volume is 1 cube, correct? Side length is 1. Final volume is multiplication of all this length. See this, 1 into 2 into 3, correct? Length into breadth into. Now, you know what you get if you multiply all this? You will get a lot of multiplications. So, see this? Each term you have to multiply with other term. Now, what we have to do is, we cannot consider every small term. We will neglect, after multiplying this, you do multiplication, neglect alpha into beta. Alpha is small, beta is small, neglect it. Alpha square you neglect, beta square you neglect. Now what you get finally? Final volume will be equal to, see this, 1 plus alpha minus 2 beta. Is it clear? Into Tx plus Ty plus Tz. This is what you get if you apply this approximation. If alpha into beta, comma alpha square, comma beta square are neglected because they are very small, okay, you get final volume as this. So, change in volume, it will be 1 plus of this, okay. Change in volume will be equal to final volume minus initial volume. So this minus 1, it will be alpha minus 2 beta into Tx plus Ty plus Tz. Is it clear? This is final volume minus 1. So 1 will cancel, you get this. So now it is the time to write the final step. What do we get? See this? Bulk modulus of elasticity. See this? Is equal to bulk stress, that is T, by bulk strain. Right? Now I will make an approximation. If all the three stresses are equal, then it will be easy for us. Stress applied for a surface is a T. For a given surface, stress applied is this. Okay? Strain is alpha minus 2 beta into 3T. This is T plus T plus T. Is it clear? So this is equal to 1 by K equal to 1 by 3 into alpha minus 2 beta. Please remember this expression. To derive this, the basic parameters you must know is the meaning of elongation strain alpha, compression strain beta. If you are able to understand it, rest is algebra. Please practice this.